Okay, so machine learning with learning agents. This is the toolkit that was introduced to Unreal last year, and I had just a short time to play around with it. It can be used to create AI bots. Again, this tool was used for gaming. It is introduced for gaming, not for research or for simulations. It was created by Unreal for the people who are creating games. So they want the bots in the game to act more human-like, not to be like bots. So that's why they introduced this plugin, and then it is also experimental, so they don't exactly trust it so far. It allows the use of reinforcement learning and imitation learning, so it is created for both of these approaches. Just a quick, very quick introduction for reinforcement learning so that we can move forward. In reinforcement learning, we have the agent, which can be, in our case, the bus. In the bus, we are taking an action that will affect the environment somehow, and the environment will also affect this agent. Then from the environment, we'll get the next state and a reward. This reward will be fed to the agent, and that's how the agent can learn by changing the policy. So the policy will get what is the state I'm in right now, and then what action it should take. And based on this reward, if it's positive or negative, it will know what action to take and how to learn. So in machine learning with learning agents, we have 4 important components that we need to add. These are the 4 blocks here. And then we have this spline. This spline we will also show later on. The spline is just the path that we want the bus to follow. So in my case, it was just a path that I want the bus to follow. And this is, we can get values from this spline, how far the bus is from this spline, to help learn from what is a positive reward, what is a negative reward. So we'll take each of these components now, one by one. First of all, we have to let Unreal understand or know which object or which actor in our scene is the thing we want to apply training to. So we have to register a vehicle as an agent. So we have a bus. We can have different buses, a lot of buses in the scene, if we would like to make multiple training sessions. Yeah. We have to register the vehicles as agents. Then the manager will use these other components, the trainer, the interactor, and the policy, to train this agent that we registered. So this is only the task of the manager, is that it connects between the agent and the other blocks for the training session. So we have the interactor, and from the name, it is how we interact with the environment, how the bus should interact with the environment. Here we have 2 things, the observations. So what exactly we are reading from the environment, for example, camera data. And we have the actions, for example, steering, braking, or throttle. These are the actions that the bus can take to interact with the environment. It's important to know that all agents will share the common set of observations and actions. So if we have multiple agents in the scene, they will all have the same observations and actions. Then we have in the blocks down, again in the blueprint. So here I was setting one of the observations, which is the position observation. As I mentioned, I have a spline, and from this spline we are knowing the position of the bus, how far it is from this spline. Yeah. So this is our observation in this case. I didn't use camera or anything, just the position. One of the important things here in the
are you taking the error?
Yeah.
Is that the state, or is this the observation?
This is observation. How far we are from the point.
The current position of us.
Not the current position, it's the difference between. The difference between them. So yeah, we can set this error directly as like the reward. Yeah, it can be negative.
Yeah, this is what I also think. That this error should be much. If you model it as a reward, it's much better
to stay far away.
How about if you are on it, then you get a positive reward, and if you are
on it, we are getting 0, not much reward.
Okay.
Yeah, but if we are far away from it, we are getting negative reward.
Negative reward. Yeah.
Exactly. Yeah, this is how it was modeled. And then we have the scaling, because as we know that in neural network, we need to normalize the data that we are getting. So to normalize this. For example, I know that the bus shouldn't stay away from the spline with more than 100 meters, for example. Then
when you are saying spline, that means you are getting some reference trajectory to that.
Yes, correct. So different goal points, yeah. So from the scaling here, we can normalize this data. For example, the bus is 100 meter away. This will be 1. If any value in between, then it will be between 0 and 1. Here is what we are doing. We are getting, for example, here the block get agent, what agent we are using. For example, we have one bus, or we have different agents. We will have different IDs for each agent. Then we get the transformation where the bus is exactly in the scene. And then here we are getting this setting observation. So it is comparing the distance between the bus and the goal point in the spline. Yeah. And as you can see, this all was done on the blueprint, so not with coding or anything. Then comes the policy. Which we don't do much actually in this block. The policy is just I use the default values. But yeah, we can test different algorithms. I haven't played with them. I'm not sure what exactly other tools we can use or what other models we can use. But yeah, I just use the default values directly. And from the policy block, it is, as I mentioned, it's taking just the observations and it's seeing which actions should be taken by the bus. It does this by inputting the observations into a neural network, which will produce the values for the actions.
And you find any policy, a behavior for your case?
Yeah, it will be shown in the investigation. So, and yeah, the model used was PPO model. So this is the default one. Then comes the trainer. This is the more complex or the most complex block of them all, and it's just we are defining how the model should be trained. What's important here to define are the rewards and the completions. The rewards we know already, so it is not visible. So from the rewards, we can define the distance as a penalty. So this is the penalty for the distance. And also I define the velocity as a reward. So if we didn't have the velocity as a reward, it can just stay on one point and it will stay in its position, right? It will always be 0 and it is not getting any reward. So we have to place a positive reward for higher velocities. Yeah, and the last thing is just getting a reference from the spline. This is the rewards. Then we have the completions.
I have a question.
Yeah.
So when we are designing the reward, so there can be multiple factors that might be playing the role. For example, if the vehicle is moving, it not should only be its position error, it should be its velocity error. Like we want to reach from one origin point to the goal point with certain speed. So when we are designing rewards, we can incorporate all those factors in that.
Yeah, correct. In my case, I just use the velocity that if the velocity is higher, this is better. Yeah, this is how it's defined. So for the driving example, we want to have two behaviors. We want the bus to drive as fast as possible along the spline. We don't want to drive far away from it. Then we are talking here about the episodes, how we define the episodes in our case, and what is called the completion. So an episode is what we want to reach. We want the bus to start from a point and then reach the goal point. This is one episode. This is what we want to reach. But it doesn't, for sure, it will not happen from the beginning. So what we have to do is this idea of completions, that if we go far away from the spline, for example, too much far away, we want the episode to start over. We don't want the bus to get stuck in a place and just, it will not learn anything, yeah? For example, if the bus went outside so far away from the spline, and then it came back to the spline with a high speed, then it will get positive reward by the end of the episode, and this is not good because it will not understand what was a good action and what was a bad action. It will understand that it went outside and came back, and in the end it got a positive reward, right? So we set these completions. If we go away, for example, 100 meters away from the spline, we want the episode to shut down and give a negative reward, a high negative reward, so that it will not do the same action later on. Yeah?
And can there be some cases of instability? And by instability, I mean if a vehicle is moving on a track and it goes outside the track, or like some accidental occurrences or something like that.
This is what we define as completion. So it went away so far from the track, we want the episode to start over. Because if we didn't do that, it can learn to come back.
But I'm saying that means if it goes off the track, then it can come back to the track.
Yeah.
Some event occurs that it goes off the track and it can it gets stuck into a point where it cannot come back to the original spline.
This can happen. This can happen. That's why also we have one of the completions is the time limit. So we have a time limit. After this time, if we didn't reach a good position, then it will start the simulation, like start the episode, and it will give a negative reward.
Also, the approach which you just mentioned to give it a highly negative reward at, let's say, 100 units of distance when it moves away, wouldn't it still be possible for the agent to move to, let's say, 99 units, still be able to come back, and the problem would still be there? Wouldn't it be a better approach if instead of thresholding it on 100, we make it like a continuous negative reward of moving away from supply?
So once when it goes away, like now the current situation is like this. Like if it's 100 meters away, it will get a negative 100 as a reward, a negative reward. Yeah. If it's between that value, it will have like get minus 50 or minus 10 or minus 5. So for the agent, it's better to have a lower negative reward, right?
Okay, so the agent is still being rewarded negatively, but 100 is just for the episode.
Exactly, yeah, to stop the episode. And actually, also 100 is too much. Like in our case, 100 is too far away from the spline, which doesn't make sense. But yeah, it's just an example. So it can be 10 meters maybe, or even 10 meters can be hard. So yeah, here, this is setting up of the completions. So in my case, the completion was the difference in how much far away we are from this spline. Once we go too far away, it will be a completion and it will reset the agents. You can understand the logic here. Again, we are getting the agent with the ID, and then we are getting the location, then its position, the nearest point to the spline. This also can be just, as you can see, it's just a block. We don't know what's exactly inside this block, but we are getting the value we want, which is the nearest point to the spline. And then, yeah, if we are too far away, then this is off-track termination. Yeah, it will terminate the episode. Then we have the learning, the trainer again. Still, we are in the same block. And here's just the logic behind resetting. So, okay, we will reset. What will happen when we reset? This is what's implemented here. And the idea is that when we reset, we want to place this agent into a random position along the spline, somewhere on the spline or somewhere closer to the spline, and then it will start again training from this point. When the episode terminates, it will also be reset to another point on the spline. Yeah. So this is the logic applied here. And again, it can look complex, but it's actually so simple that we have these three blocks are adding random values. We're getting the location. We are getting the location at a distance along the spline, any point on the spline. And then we are giving this as a point to the bus. We are adding some random value to the X and Y, and also rotation, the orientation of the bus. Yeah. So we'll place the bus on any point, random point, with random position, like a range of positions away from this point, with different position and different orientation, which are selected randomly. Yeah, then we are just giving the action to set the actor transform. So the vehicle will be set in this point.
And is it always possible for the agent, because the target point for the agent might be so far away that it is not directly in its observation space? So is it always possible for the agent to make a spline all the way from its own location to the target? Or does it only makes possible trajectory up to a certain point?
I could understand the question exactly. So
when we talk about spline, it is basically like a reference trajectory from the agent's location to the target location, right?
Yeah.
Is it always possible for the agent to see as far as the target so that it can make a spline all the way to the target? Or is it a certain distance up to which the spline or the trajectory is being made?
I mean, like here we are defining how much far away we can be from that point. Yeah, so we are setting it some very low value. We don't want to be that far away from the spline. Like it's not like it can be 1 meter, 2 meters away from a point on the spline. So the spline is just a path. It can be a road. Yeah.
And is it hard-coded, or can it adjust along the way, seeing different dynamic obstacles? Will the spline be adjusted while the agent is
No, it's a fixed. So in this simulation, I didn't use even the pedestrians. I didn't add pedestrians. it was a stable and static environment.
Basically, the objective of the agent is not to reach a target. It's the objective is to follow this plan.
Yeah, exactly. So yeah, like the logic itself, it is not that useful for me even like to run the simulation, but it is just to test the tool and see how it's working. Yeah. Then yeah, an important point is that we can have multiple agents with this plugin, so we can have a lot of buses in the scene, and they can all train at the same time. This can be set here on the maximum agent number. 32 is a too high value. In my case, I use just 5 different agents. Simulation crashed a lot, but yeah, like it managed to work in the end. The tick interval is just how often we want an action to be taken by the bus. So if our simulation is slow, then we need to reduce this value, because if the simulation is slow and we are giving action every like 10 times a second, the bus can skip these actions, right? We can give, for example, throttle value, but the simulation is not running, so this value is just lost in between. Here is just the log output. So these agents, for example, are resetting when reaching, for example, when an episode is over. And you can see here, for example, these all are reset at the same time. This can be that the time of the episode reached and they didn't reach any goal, so they all reset at the same time. Then we have just showing that it is PPO model being used, and here we can read the average reward we are getting in every episode. After training, we can do inference. So we have now a model. We need to add it to the agent. To do that, we have to stop training and remove the blocks for training, and then we can just run inference, which will get the policy that we just created. So it's just too simple, just one block we will add. Now running the simulation. So again, the idea quickly is that we have a blueprint for the manager and different components were added to the blueprint. The spline was created, and this is where we are getting our observation from. Then running the simulation, number of agents were placed randomly along the spline. In my case, it was 5 agents. Training will start as discussed before, and then once the results are satisfying, training can stop and we can do inference. Here is what we can see. The white line is the spline. This is the spline in the environment. This is how it looks from a top-down view. And again, this is the spline. So we want the bus to follow this line, yeah? These are splines and not used for training. These are splines to create the environment. So this is not for training purpose, yeah? Like this one. This white one is the one used for training. The other ones are splines just used for the, like for example, to create these things here. Okay, now this is when starting the simulation. We have 5 different buses. So the spline again, it is not visible here. The spline is moving from this direction. So they are placed randomly, and you can see the orientation is also random. Here is during the training. So the bus is moving along the spline, but they are a little bit far away, and also the orientation is not correct, as you can see. This is after training for around 20 minutes. And you can see again the spline is not that visible. It's that, and the buses are starting to move on the spline. So after these 20 minutes, I stopped training and I just used whatever model I had with the inference. And this is how this is a video. So this is how it runs with the inference. It is also good to notice that the steering is too much. It's doing too much steering. This also we can give a negative reward for this now if we want the steering to be stable. But currently it was not, so it was steering too much. It is not avoiding pedestrians or anything. They are just in the scene. Yeah. So pedestrians are just in the scene and they are not trained in this. Yeah. You can see the random action that they just started running from.
you should comment on the accuracy now after 20 minutes of training. And accuracy in a way, how good the behavior seems. Is there any way to find out this?
I mean, we can get the average reward on that these values, but I mean, since it is going from the start to the end point successfully, it is good enough for me.
Is it good enough, or you don't want to exactly follow the path of the spline that is?
Yeah, I want it to be on the path. So whenever on the path, it's good. Since it's going in the path and not hitting any obstacles, not hitting any static objects on the way, not getting outside of the path, this was good enough.
Unreal is basically a completely software simulation model. Is there any hardware in loop simulation that you guys do before putting that system into the real world? Basically, I mean to say that you simulate the actual hardware through this simulated environment and then check the triggers or actuators on the actual hardware.
We didn't do that. Like currently, we don't do that. So we just take, if for example I want to test this, I will just take the model and run it on the real system, like, which is not safe, but
That would be completely software-based simulation, right?
Yeah. exactly.
But you can also get the real world data also and train on both of them, huh?
The real data, yeah. So if you want to get the reward and not the reward.
Because here you are using the positions and the error, you can also make that the same thing here. But obviously you cannot afford to have go that you afford to have this auto bus or this bus going in another path or
Yeah, exactly.
crashing somewhere else
Yeah.
outside the path.
And the idea in mind is to try to run this same idea but with using images, and then we can use the images even from the real world to train the model. But currently it's not. No.
When you are training the model, because I have worked on a project for UAVs in Unity 3D. So I want to compare the two softwares. Is it possible in Unreal Engine to have multiple training episodes being run at the same time?
Yeah, you mean agents or simulations? So in this case,
Simulations.
two
Or
different
let's say
simulations.
episodes.
Yeah, like
The
currently,
episodes always be carried out sequentially, or is it possible to have multiple copies of the same environment and they are trained parallel?
I haven't tried to run different simulations, but in my case, I'm running 5 different agents. Like these are 5 different agents. They are training on the same simulation.
And all of these agents are training the same model.
Yeah. Yeah. So that's it with this tutorial. We can
Also,
do
one more question linked to this. Do these agents see each other while they're training?
No, they are not visible. We are not using camera at all, so they are not visible. What I had to do is to just remove the collisions from the bus, so they don't have collision values. Yeah? So we can hit each other, but they don't know that they exist.
So, for example, let's take the example of this spline which you just showed.
Mhm.
You trained it for 20 minutes, the bus starts to move on the spline. Is the bus trained on that particular spline, or will the bus follow any spline after that?
Yeah, it should follow any spline after that. So no, but in this case, like it can be placed on any point on the spline. So how it knows, like it can be placed on any point in the spline, it will follow the spline. So it is the same idea, I think.
So suppose this spline is for one route.
Yeah.
When you want the bus to go on another route, someone's gonna have to. So you have to start completely from scratch for that.
No, we can set the spline directly, and it should follow the new spline.
But what if the spline's trajectory is different from the initial?
Because here the idea was not to follow a specific spline. The idea was to follow goal points. So we are feeding goal points. It will go to these goal points. This is what it is learning, not the exact spline. If we want to teach or to train it on the exact spline, we can start from the same position always. Yeah. So we have to start from the same point every time we train. That way, it will exactly follow the one spline. But what we are doing is that we are setting it on different points on the spline. Yeah.
that is actually the reason why you train it on the relative distance between the goal points
Yeah.
instead of the actual
Correct.
coordinate.
So you can see, for example, here it was sunset time. Here it was a daylight time. Yeah. So we can change this. We can change if we want to add smoke, rain, fog, this stuff we can.